In July 1994, astronomers around the world watched something that had never been witnessed before in human history. A comet was about to collide with Jupiter. Not just one impact, 21 separate fragments, each one massive enough to destroy a continent on Earth, were going to slam into the largest planet in our solar system over the course of 6 days. And we had front row seats. This wasn't just an interesting astronomical event. This was the moment we realized that Jupiter isn't just the biggest planet in our solar system, it's literally the reason we're alive. Let's rewind to March 1993, over a year before the impacts. Carolyn and Eugene Shoemaker, along with their colleague David Levy, were scanning photographic plates of the night sky looking for asteroids and comets. They'd done this thousands of times before. It was routine work, but on March 24th, they found something that wasn't routine at all. There was a comet near Jupiter, but it looked wrong. Instead of the typical bright nucleus with a tail, this comet appeared stretched and fragmented. It looked like a string of pearls spread across the photograph. Further analysis revealed the truth. This comet had already been torn apart. At some point in the past, it had passed too close to Jupiter, and the planet's immense gravity had ripped it into at least 21 separate pieces, each one still following the same orbital path. They named it Comet Shoemaker-Levy 9, or SL9 for short. And then they calculated its trajectory. The comet fragments weren't just passing by Jupiter. They were on a direct collision course. Every single piece was going to hit the planet in July 1994. For the first time in history, we would watch a cosmic collision happen in real time. The scientific community went into overdrive. Every major telescope on Earth was pointed at Jupiter. The Hubble Space Telescope cleared its schedule. NASA's Galileo spacecraft, which was already on its way to Jupiter, repositioned to capture the impacts. Even amateur astronomers with backyard telescopes trained their instruments on the gas giant. But there was uncertainty. Would we even see anything? Some scientists predicted the impacts would be spectacular, creating fireballs visible from Earth. Others thought the fragments might just disappear into Jupiter's atmosphere without much effect, like throwing pebbles into an ocean. Nobody really knew what to expect because we'd never seen anything like this before. The impacts were scheduled to begin on July 16, 1994. The world watched and waited. Fragment A hit first. The impact occurred on the far side of Jupiter, hidden from Earth's view. But as Jupiter rotated, the impact site came into view about 20 minutes later. What astronomers saw left them speechless. There was a dark scar on Jupiter's surface, bigger than Earth. A massive plume of material had been blasted 1,800 miles above the cloud tops. The impact site glowed with infrared radiation, hot enough to melt rock. Fragment A was one of the smaller pieces. Over the next 6 days, 20 more fragments slammed into Jupiter. Fragment G, the largest, hit on July 18th and released energy equivalent to 6 million megatons of TNT. That's 600 times more powerful than the entire world's nuclear arsenal detonated at once. The impact created a fireball so large it could be seen from Earth with amateur telescopes. The dark scar it left on Jupiter's surface was larger than the Great Red Spot and remained visible for months. Each impact was like watching a global extinction event happen on another planet. The kind of collision that killed the dinosaurs 65 million years ago, except happening over and over again in the span of a week. And then came the realization that changed everything. Jupiter isn't just big, it's positioned perfectly. At 318 times the mass of Earth, Jupiter's gravity is immense. Objects in the outer solar system get pulled toward it like water circling a drain. Comets that would otherwise drift into the inner solar system and potentially hit Earth get caught by Jupiter instead. Scientists began calculating the numbers, and they were staggering. Without Jupiter, Earth would be hit by catastrophic asteroids and comets up to 1,000 times more frequently. Not small rocks that burn up in the atmosphere. We're talking about civilization-ending impacts, planet-sterilizing collisions. The asteroid that killed the dinosaurs was about 6 miles wide and released energy equivalent to 100 million megatons. Fragment G from Shoemaker-Levy 9 was comparable in size, and there were 20 more fragments behind it. Without Jupiter, events like this would happen on Earth not every 65 million years, but potentially every 65,000 years. Human civilization is only about 10,000 years old. We wouldn't exist. Jupiter has been taking hits for us for 4.5 billion years, and it shows. Jupiter's atmosphere is constantly churning with storms and disturbances. The Great Red Spot, a storm that's been raging for at least 400 years, is larger than Earth. But mixed in with the natural weather patterns are impact scars from objects that Jupiter has captured. In 2009, amateur astronomer Anthony Wesley spotted a new dark scar on Jupiter. He wasn't even looking for it. Professional astronomers confirmed it was a fresh impact from an object that hit the planet just hours earlier. Nobody saw the object coming. Jupiter caught it before it could drift closer to the inner solar system. It happened again in 2010, and 2012, and 2016, and 2019. These aren't rare events. Jupiter is constantly being pelted by objects that could threaten Earth. Most impacts are too small to see from our distance, but they're happening all the time. Jupiter is a cosmic shield, and it never stops working. Let's imagine for a moment what Earth's history would look like without Jupiter. The asteroid that killed the dinosaurs wouldn't have been a rare, once-in-an-era event. It would be routine. Massive impacts every few thousand years, each one resetting the evolutionary clock. Complex life might never have survived long enough to develop intelligence. Every time a species started to dominate the planet, another impact would wipe it out and scatter the survivors.
The Cambrian explosion of complex life 541 million years ago might never have happened. The rise of mammals after the dinosaurs might have been cut short. The evolution of humans from primate ancestors definitely wouldn't have had time to occur. And even if somehow, against all odds, humans did evolve, civilization would be impossible. You can't build cities, develop agriculture, or advance technology when extinction-level impacts happen every 100,000 years. We exist because Jupiter exists in exactly the right place at exactly the right size. Today, we have telescopes and satellites constantly monitoring near-Earth objects, asteroids and comets that could potentially threaten our planet. We've cataloged thousands of them. We even have plans to deflect dangerous asteroids if we spot them early enough. But the vast majority of objects that could hit Earth never make it to our neighborhood because Jupiter catches them first. Every day, Jupiter's gravity is bending the trajectories of comets, pulling in asteroids, absorbing impacts that we never see and never need to worry about. In July 1994, the Shoemaker-Levy 9 impacts showed us this protection in action. We watched Jupiter take 21 bullets for us in less than a week. Those dark scars on Jupiter's surface weren't just impact sites, they were proof that without this massive planet standing guard, Earth would be a very different place. Or more likely, there would be no Earth at all. Not one with life, anyway. Jupiter doesn't get much credit in popular culture. It's just the big striped planet with the red spot. Kids learn about it in school and move on to more interesting planets like Saturn with its rings, or Mars with its potential for life. But Jupiter is the most important planet in our solar system, besides Earth itself. It's been protecting us since before life even existed on our planet, before the oceans formed, before the first single-celled organism ever divided. For 4.5 billion years, Jupiter has been out there, silent and patient, absorbing cosmic punches so we don't have to. And it will continue doing so for billions of years to come, long after humanity is gone. So the next time you see Jupiter in the night sky, that bright dot that outshines most stars, remember what you're looking at. You're looking at the reason you exist. You're looking at the planet that saved Earth.